Okay, so we're going to start with the first lecture today using this technology. You can see the lighting's not perfect. I'll be continuing to try to improve that as we go, and hopefully this will work. Topic of today's lecture is what is a fluid, and the definition is pretty straightforward. A fluid is a substance that is permanently deformed by the application of shear stress, no matter how small the stress is. So that's our definition. A fluid is a substance that is permanently deformed by the application of shear stress, no matter how small the stress is. In order to understand, what that is relative to a non-fluid, let's consider the non-fluids first. So basically, the world's going to be divided for us into solids and fluids. And so let's consider solids. And you've studied solids already many times, but particularly in mechanics and materials. So let's consider this solid. It's going to be a solid that is attached to two different plates. It's going to be attached to plate 1 and plate 2. And the solid is in between these two plates, and it's attached to both of them. So there's your solid. And what's going to happen here is we're going to actually apply force to plate 1. So we're going to take plate 1, and we're going to push on it with some force. I'm going to call that force F naught, and push plate 1. And because it's stuck to the solid will deform. And so what will happen is you'll get a small deformation of the solid. Obviously, the size of that deformation depends entirely on what the solid is. If the solid is something like aluminum or steel, and the force is not particularly great, you're going to see a very, very small deformation. On the other hand, if it's something softer, like an eraser, or some kind of, not particularly hard thing, then you're going to get a deformation that you can actually see. But whether or not you can see the deformation, you're definitely going to have a deformation. The object has to deform because you're applying force, and so because you're applying force, the top plate is going to continue to move until the opposing force, which is provided by the solid, becomes equal to the applied force. So what happens then is that the solid obeys, simple Hooke's law, which you know. So the solid, as it deforms, the force exerted by the solid, F exerted by the solid, is equal to minus kx for small deformation. And this is true of all solids. If you deform them only a little bit, then they respond as a perfect linear spring. So for small deformation, we can say that this is true. Of course, this is Hooke's law. And the top plate will stop moving when F solid, of course, is the opposite of the applied force. So plate will stop moving. So that's when that will happen. So obviously, if you take that together, you say, well, that means that minus F naught will equal minus kx. And so x, which is the amount the top plate moved, is going to depend on the force. And that makes sense. If you apply more force, you're going to expect that x to be larger. And of course, if you apply less force, it will be less. And it will depend on this k, which is the spring constant in Hooke's law, but it depends on the elasticity, the strength of the material, and so you can calculate how much it would actually deform based on what the power of that k will be in that particular situation. But the main point here is that there will be some deformation. Even if the force is extremely strong, there will be a small amount of deformation. But if this deformation is small, then when you relieve that force, it will spring back. So your thing, if you relieve the force, your solid and solid goes back, returns to its original shape. So we're back to where it started. So if you stop pushing on it, it just goes back like a spring, because it is like a spring. So that is a not permanent deformation. Yes, the solid deforms when force is applied to it, when a shear stress is applied to it, but it does not remain deformed. If you remove the stress, the solid will return to its original shape. And that is what liquids do not do, right? So liquids will not do that. Even if you apply a very small amount of stress, they will permanently change their shape. Now, we also know that for a solid, you can put enough force onto it that it won't go back to its original shape, and that's called plastic deformation. And you know that, again, from mechanics of material. And so we know that solids under a lot of force will, in fact, permanently deform, and eventually, of course, they will break. But that's not the same as liquids, which always deform, even under very, very small forces. So here's the conclusion. The conclusion in terms of what makes it a fluid is solid objects do not deform permanently. Solid objects do not deform permanently. When subjected to small shear stress. How small depends on the solid. But this is actually the practical definition of a solid for us. So if it's something that's so small, when you apply, and if the shear stress that will deform it permanently is so small that it's like immeasurably small, then obviously it's not really going to be a solid, because as soon as you try to pick it up, there's going to be some kind of shear stress, the whole thing's just going to fall apart. So that is really why we call it a solid. And so solid objects, not like fluid objects, retain their shape because they can withstand small amounts of shear stress without permanently changing their shape.